Hi everyone, welcome back. This is a continuation to the previous video in which we have seen singly linked list insertion, and we have also seen that there are three different cases under singly linked list insertion. Insertion at the beginning, insertion at the end, and insertion in the any random location. So in the previous video we have seen insertion at the beginning. In this video we are going to see insertion at the end. So here, for inserting a new node in singly linked list at the ending, we need to modify two next pointers. One is the last node's next pointer, another one is the new node's next pointer. So there are two steps in performing this operation. The first step tells us that we have to make the next pointer of the new node to null. That is the first step. The second step tells us that we have to make the next pointer of the last node of the list. This is the last node of the list, as we can see in the diagram. So we have to make the next pointer of the last node to point to our new node. So these are the two steps for performing the insertion at the end of a list. But as you might have realized by now that this process is not that easy as it seems to be. The reason is that a computer does not know which is the last element of the list. In our previous video, in the first video of the series, we have seen traversal, where we have seen how to find, how to start from the first node of the list and go till the last node of the list. So we will be using that concept here. We need that concept here. You may ask why? Because an algorithm that we are going to write needs to confirm which node is the last node before it can insert a new node after that last node. Just by seeing the diagram, we know that 7 is the last element of the list, but a program does not know that. And so we have to write code in such a way that the program starts from the first node of the list and goes to the last node of the list and finds out that this is the last node, and you know already how to check whether this is the last node that we have already seen in the list traversal. So once we reach the last node of the list, then we can perform this action as you can see here. Let us analyze the steps in detail for insertion of a new node at the end of the linked list. So the first step is always to create a new node in which we can store some value and whose next pointer can be used to insert this particular node into the list. To perform that, we have this code, as you might have seen it in the previous two videos. This is the basic step that we must perform. That means we have to create a new node of type list node and then assign some memory to it. That is the first step of creating a node. And then once the node is available, then the next step is to make sure that we move from start to end before inserting the element. That is what we have seen in the previous slide. In the previous slide, we have learned that we need to have a traversal from first node of the list till the last node of the list, so that once we have the list's last node, we can insert a new node at the end of the list. So for that, we have already learned that we need traversal, and this is a code of traversal. This code is somewhat similar to the code that you have seen as list traversal, but this code is a little bit different compared to the list traversal. The only difference you see here is the condition of this loop. This condition tells that as long as next of current is not equal to null. So why are we writing this condition here? Let us see. First of all, we are pointing current with start. That means we are pointing current to point to the first element of the list, and then we are checking if the next of current is pointing to null. So next of current, that is the first node, is not pointing to null. As you can see, it is pointing to the element 15. So because this is satisfied, because the next of current is not pointing to null, we are going inside the loop and we are moving the current to the next element. So the statement we have already seen in the previous video, so I hope you understand this statement. So once the current has been shifted to the next element, that is, now current is pointing to the element which stores 15 as a value. Now we again check whether next of current is pointing to null. So we see that next of current is not pointing to null, and this condition is satisfied. That is what we are checking. Next of current is not pointing to null. So because this condition is satisfied, we are moving current to the next element again. So now current has been moved to the next element. Now current is pointing to a node whose value is 7. Now we again check whether next of current is pointing to null. And yes, as you can see, this particular next is pointing to null. And that is exactly we don't want in this condition. This condition is checking the opposite of it. As long as next of current is not equal to null, we have to keep looping. That means as long as next of current is not equal to null, we have to move current to the next element. And once we reach an element whose next points to null, we have to stop. And so this condition tells us that when you reach an element whose next points to null, that means you have reached the end of the list. So once you have reached the end of the list, that means we are currently at the end of the list and we can start inserting a new node at the end of the list. So our next step is this, in which currently we have the last element being pointed by current, and we already have a new node whose next is pointing to null, as you can see here. We are currently having a node whose data is not assigned yet, and currently we just have a memory location pointed by new node. Now our first step after we have reached the last element is to make this next pointer of the new node to null. That is the first step that we have seen in the previous slide. So we are making it here. Next of new node point to null. And the next step is, once you have made this next of new node to point to null, the second step is that we have to take the next of current node, as you can see here, next of current node, and make it point to new node. So next of current, make it point to new node. So this whole code gives us a way to traverse from the first node till the last node of the list, and once we reach the last node of the list, insert our new node at the end of the list. Let us see that whole code put together in a single place called a function, and we are calling this function as insert at end, and this function is receiving a parameter called value of type integer. This is exactly what you have seen in the previous video of insert at beginning, where we have also received a value, and you know exactly what is the purpose of this value from the previous video. We use this value to assign the value to data variable of the new node. That is exactly the purpose of this value. And other than this particular statement, everything else is already explained in the previous slide. As you can see here, we are having a statement to allocate memory to our new node, and then we are assigning current to start, and then we are having a loop where we are moving current till the last element by checking this condition. And once we reach the last element, we are making the next of new node to point to null, which is the first step, and we are making the next of current to point to new node, which is the second step to perform the insertion of a new node at the end of a list. So this concludes our video of insertion of a new node at the end of the list. Thank you.